When the history of computing will be written, I'm sure Google will be noted as a major milestone in the development of information science and information management. We are coming to an end of an era, and therefore we have to understand that Google represents a future of computing in a different way, and I'll explain why this is so. I want to preface my remarks by saying that you should not buy Google stock. This is not a Google stock promotion here. Google, in fact, as a company may fail. That is not the point I want to make here. I want to just say they are the harbinger of change that will be imitated and copied, and will then set the tone for many of your careers. The students in here, judging from their age, represent maybe a generation that will be managing and providing leadership for information technology from year 2010 through year 2065. If that is so, then the understanding how Google thinking changes the environment becomes a very important part of your education. History is very important in understanding where we have been. Basically, the dimensions of change over the last 50 years can be quantified in terms of sources and time delay responsiveness. And during the data-centric era, we had hundreds of sources impacting a corporation, and gradually going from monthly to weekly cycling of information as the information technology applications moved from finance, which was basically a monthly animal, to marketing, which became a weekly animal. In 1980, the demand for responsiveness and utility shifted, and in this particular area, which I, for lack of better definition, call the work group-centric area, we have created millions of islands of automation centered around servers. But these were little cottage shops, some of them growing to substance, but nevertheless being scattered, not integrated, not interoperable, not very reliable, and having a rather slow way of responding to external situation. This is what I call the Microsoft Intel era. The Google era, which I will be discussing today again, this is symbolic, deals not with data or text, but with multimedia. It deals with billions of sources of information and basically shrinks the information latency to real time. And by the time we go into the generation of 2015, 2025, real-time responsiveness then becomes the currency under which systems operate. These systems I call network-centric. I use just one of many examples, but I'm sure you recognize this particular diagram. This is where an real-time interaction between satellites, drones, aircrafts, cruisers, guided missile launchers, and so forth are necessary in order to execute a mission. Now, this is a military example, which is appropriate in the setting here in the Washington area. But even when you start looking at environments like Federal Express, for instance, they are all going to a network-centric real-time environment. So we are already moving in that direction. Now, here are the specifications, ladies and gentlemen, that you will have to deliver in your careers. First, the system that you deliver has to be extremely reliable, has to be down less than 5 minutes a year. that's 6 to 8 sigma reliability. You must be able to represent the real-time awareness of the situation in a very fine, very rapid color, high discrimination display. You must be able to tap into a multimedia environment at least at gigabyte per second. The latency cannot exceed more than a quarter of a second globally, anywhere in the world. And if you want to innovate and change the environment, you must be able to innovate in less than a day, while at the same time assuring security to an extremely high level of fidelity. So those are, ladies and gentlemen, the tasks before you. And you don't have much time to deliver because there are customers out there who want exactly meeting of these kind of specifications. Now, the good news is that it's an awesome opportunity, because when you compare what we have today in the client-server groupware kind of a group work environment, we look pretty sick. Let me just give you the highlights of what I see, typical specifications. First, when you look at any budget of any larger corporation, and certainly when you look at any of the government budgets, especially in the Department of Defense, much of the effort of the IT spending is devoted strictly to staying alive and getting the thing patched so that it sort of doesn't fall apart. I call that the infrastructure. Over 50% of the money is being spent by people running around. During the break, I talked to a number of you who are night students, who are systems administrators, who make a living by making sure that there's paper in the printers and that nobody has kicked the cables on at the desk and so forth. But you are part of infrastructure, which is important, but there is no way of creating value just from the infrastructure. I deliberated very much on the subject of what is the current performance of security. The only quantitative number I could find was a non-Boolean question mark. When you look at the cost of fielding an application, you find that much of the wedging of an application into a systems environment consists of integration, sort of just splicing things, performing neurosurgery on a runner who is bleeding. Now, that's a good analogy. And then, of course, you have network downtime, and I'm being very kind, but network downtimes, particularly on email availability and many of the operational functions, is deplorable. And if you want to innovate anything, you have to have a feasibility study, and God help you if you have to go through DoD acquisition. That can extend infinitely and indefinitely. So here is the gap between what is needed and what we have. The question is, can we get from where we are to where we are going? And the conclusion is very simple. Namely, that you cannot design network-centric systems with the existing workgroup-centric architecture. Just not doable. You cannot design an airplane using railroad technology. Just another example. Even good trains don't fly. So this is a very important good news, bad news kind of a slide. The good news is that we know where we need to go. The bad news is that all those of you who are wedded in your careers to workgroup-centric architecture based on what you study these days is going to be obsolete. So you might as well get ready for a different view of the world of the future. And here are 4 principles which I see are manifested in Google. And there are, of course, many variants on this thing, but here it goes. First, if you want to have reliability, if you want to have uptime, if you want to have redundancy, you have to build and operate a protected information network. The current Internet is not a protected information environment. What you have is an outgrowth of a very clever DARPA, actually ARPA, research effort built by the professors, for professors, and for students. All you have now is an extrapolation of that. That is not going to be robust enough to meet the requirements. So if you want to build your secure environment on the existing second generation workgroup environment, Internet, it won't work. You need a different environment. Second, you have to offer universal connectivity for collection, processing, storing of information, and you must provide secured communications. Now, the principle number 2 is a mouthful, which leads really to principle number 3, namely that in order to achieve the interoperability and the collection, you must maintain shared data models. In other words, when you study the Bible in the book of Genesis, chapter 11, you may, those of you who are biblical scholars, remember that when the good Lord wanted to confound human affairs, he scrambled the data dictionary. Now that's a loose interpretation of the Bible, but I'm sure you get what I mean. We must have shared data models in order to have interoperability across various functions. But 4th is actually the most important one, is this cannot be planned. The future cannot be planned as some kind of a master design. It has to be evolutionary. It cannot be obtained by issuing an RFP to the usual Beltway consultants saying, well, give me a network-centric design. It just cannot be done. The network-centric principle, as I will demonstrate in a moment, depends on continual upgrading and innovation and experimentation. So what I will now do, rather than talk in abstract, I will use the Google principles as an illustration of how these principles are actually executed. The first one is building and operating a protected information network. The fundamental reality about Google is not a search application. Google is not a search application. It's the only way how they make lots of money. It's the only way, it's the secret juice that they get, the secret formula for getting up what is basically a massive parallel processing environment consisting of clusters. And in each cluster, you have racks, and in each rack you have machines, you have multiple CPUs, and basically you have clusters, and whether there are 20 or 40, nobody knows. This is something that is held very tightly. But the underlying fact about the reality of the Google architecture is the fact that it is a massively parallel machine consisting of lots of clusters, which consist of lots of servers, maybe 200,000, maybe 300,000 servers, all connected, all working together. And therefore, what Google has is the world's largest computer. Although it is in small pieces, a fairly simple machine. Once you hook up logically 100,000, 200, or 300,000 servers, you have a supercomputer, the likes of which nobody has ever seen. Now, I also want to point out to you that the way how these things are done is that each of the clusters has basically the same architecture. In other words, each cluster has what's called an index, an awareness of what exists in the network. It has all the documents. In other words, I will be showing you, for instance, references to Paul Strassman in Arabic. Just happened to hit on that. That is most likely hosted in a document server in Singapore. It's surely not being hosted in New York or in Washington. But if you make an inquiry in Connecticut, the index server would know that this record is available in Singapore, and that the duplicate of that record is also backed up somewhere in the Pacific, and then brings that particular application through a web server into a web switch and brings it to my desktop in New Canaan, Connecticut in less than a quarter of a second. And so it is the duplication of identical architectures which is the secret sauce of Google. It is the massive parallel application of enormous amount of computing power in a very organized way, self-aware as part of the network in order to find information and then combine information from various sources. Those of you who are involved in the arcane art of building data centers, I was able to, by some subterfuge, actually show you a picture what a cluster looks like. I was told, and this was an internal, when you do a search on Google, they really give you very little information unless you get a little devious. And once in a while they slip up, and this particular operator claimed that they put it up in 3 days. Subsequently, I found out that setting up a Google cluster in 3 days is just too slow and too labor intensive. My latest intelligence, which I'm revealing today for the first time, is that Google has now containerized clusters, and they can be drop shipped and put up in less than 8 hours anywhere in the world. Now, it has vast implication from the national security and defense standpoint, because this is exactly the kind of capability you need in the battlefield. So, what is then the secret to Google? It is the infrastructure. You have over 200,000 custom-built commodity servers. These are custom-built by a foundry in Taiwan. This is no fancy architecture, no RAID disk. These are off-the-shelf, low-cost boxes. By the way, you can buy one of those boxes with some reservations so that you could actually have a look at these things. These are basically pizza-like kind of boxes. You slide them in, and they are built as a fault-tolerant hardware, which means any one of those servers, when they fail, don't matter. They are not only plug replaceable, but immediately at least one, and sometimes as many as 3 servers pop in, because the index knows where the backup is. Now, I don't know whether your classes include petabytes as a scale, but a petabyte is 1,000 terabytes. A terabyte is thousands gigabytes. Very quickly you can sort of multiply the numbers. All we know is more than 5 petabytes and growing rapidly. Each server has 80 gigabytes, although as the disks become cheaper and the prices drop, they just yank out the disks and factory refurbish it and just put it right back. One of the interesting aspects of the servers on the Google network is that when you move from Pentium to whatever the next gizmo is, it doesn't matter because the functionality is not dictated by the microprocessor, which means it lowers the cost. You must understand everything that I'm describing here is dirt cheap. It's standard, low cost, commodity hardware. When I compared some of the costs for infrastructure, the cheapest next infrastructure is that of Sun Microsystem, which in my view is at least 4 to 6 times more expensive than this particular configuration. When you add the bloated Microsoft server environment, you are dealing with a large multiplier of cost. So you must understand what drives this particular environment is cost, cost, and cost. Now, cost doesn't come for nothing. The way how you compensate for the fact that you have lots of cheap hardware, you compensate it by software. And that means that in addition to serving machine cycles from the customer, which is you, most of the machine cycles are really devoted to the system operating itself and becoming aware. In other words, the data gets moved in the whole global network as demand arises and certain frequency distributions take place. So this is a massively parallel, self-adjustive, self-healing, self-adaptive environment. The complex is mathematically very complex, the indexing is complex. It is a 500 million by 2 billion matrix. If there are any operations research people in here or mathematicians, they would understand this is an awesome mathematical exercise, which of course operates during the time as the demand circles around the world. There's always machines and clusters who are not active, and during that time the machines just go and work on themselves. By the way, this is the way the human brain works. The reason you need sleep, whether you know it or not, is you need idle time for your sensory perceptions in your brain to be re-indexed. That's why denial of sleep is basically a way of ultimately disorienting a human being. Your brain requires sleep. In their particular case, it's called indexing, re-indexing. The capital and operating costs are a fraction of commercial servers. It's extremely scalable. The traffic is growing 20 to 30% per month. You sort of wonder how long can this go on, and we don't know. But the data centers are growing and being drop shipped as conditions warrant. Now, because we are here in the national security area, I want to point out that replication is the way how you deal with reliability. Much of the inheritance from the IBM and Microsoft era is that if you want reliability, you'll just pile on more functions, more code, and more self-up. You just put more code into an operating system. Their operating system is really a stripped-down Linux version, proprietary, by the way. But the reliance is on redundancy rather than on layering software. And the replication is done for proximity and response, which means you replicate depending on the way the demand appears. So for suddenly, there is interest in New Orleans. Many of the data that deal with New Orleans would be moved from wherever they are to where the demand would be arising. I think those of you who are in the Department of systems engineering and software should understand that reliability can be achieved with software and architecture, not with hardware. Those of you who understand the way we do reliability now, right now, for instance, if you want a reliable desktop, you will take your hard disk and make it a RAID disk, a 2-up RAID array or a 4-up RAID array. They don't have any RAID in the system. The whole system as a system is a RAID. So you then rely on indexing for response by moving transactions and data to point of use. We do this dynamically, and by the way, it's easy to do indexing of text. They are now doing indexing of images, which is really the future challenge. And that dynamic indexing is very demanding. And of course, you start taking messages. And the way you do it is you take the index and you break up the index. So the index is not in one place. The index is broken into what they call shards. And they are distributed across data centers, so you could kill any one data center. Now, I have no evidence, corroborated evidence that this is so, but there was a particular moment for a number of reasons where they lost half of the shards, and they were still operating only with a small delay in latency. Now, how does this work? Well, the issue really has to deal with the query serving infrastructure. In this kind of a distributed environment, you cannot think in terms of a particular server that has a particular database or an Oracle file and so forth, and you hit it against and you want an answer. You really, when you assemble a display, and I'll be showing you some displays in a moment, you may have to go to many places where there are pieces of this display. There are pieces to the answer, but you never know how the question will be asked. And the question is not standard because the question can be totally improvised. It can be in different languages, which I'll be demonstrating to you. There's over 80 languages in which a particular question can be asked. Yet the answer still has to come out to a particular desktop in the context of that inquiry. And so that means that in order to answer certain complex questions, particularly if the question has some Boolean searches, you may actually involve the cooperation of more than 1,000 servers, index servers, data servers, and web servers in order to answer that particular questions. And that means that the document servers also have to then look at the pieces of information which fits a particular inquiry. This is a subject, this slide alone would be worthy of a semester of a course in engineering. Now, how do you in the world keep this thing going? Particularly if you keep popping in these clusters, drop shipping them, and then plugging them in and they're supposed to take over. They have a highly proprietary system called the MapReduce server system, which is highly proprietary. And they basically coordinate all the servers in real time and distributes the workload so that if the workload, and I've seen the diagram of the workload shifts with the time zone in which you operate. And therefore, in order to optimize the use of the system, you basically have to distribution of the workload in order to keep both reliability and latency up to date. And you also must have a capability in this environment to reconstitute the service in case any particular server or pieces of a cluster or a component fails. And therefore, you must have an operating system the likes of which the world has never seen. And it's not an operating system, it's basically a master scheduler, which then monitors the performance because it's really an automatic system that keeps track of itself. Okay, so far this has been easy. I hope you appreciate the elegance of this, but it's a tough order. And some of you who have been in this business for a while and you have built systems, data centers or client server system, understand that this is a degree of complexity, several orders of magnitude over what is your experience. Now let's go now to the second principle, which is universal connectivity. By the way, before I finish, I want to point out to you that all my presentations here come with a 90-day warranty, which none of your professors ever give you. My warranty consists of the fact if you have any question about a specific slide and you have the handout, you can email to me the question, and if it's decent and answerable and not a request for free consulting, I will put it on the blog so you'll be able to see who is asking what questions. Okay? All right, universal connectivity, principle number 2. When we say universal, it means that it has to interface in many languages. Although English is a dominant language among computer experts represent only a tiny fraction of the human population. And the question what proportion of the human intelligence it represents is still arguable. Nevertheless, the world is multilingual, multicultural, and here's an example of how the various languages get responded to. I know some of these languages. I tested it and I was amazed. Again, here is my inquiry, and apparently I was able to find a quotation in Iran in Arabic documentation published in Philadelphia, of all places, and then some kind of a reference to a quotation. And these were searches of Arabic pages. Again, I'm just showing to you this as an example of connectivity. Another example of connectivity, which is not only text, is that you may wish to go back and actually go to Google Video and see my prior presentations as well as this presentation that will be posted after Google will make sure that this is decent and wholesome and doesn't violate any laws. So you'll be seeing my presentation of today most likely in about a month or so. Now here's one that is sort of interesting. This is a new application called Google Base. And in a moment I'll be talking more about applications and innovation. But now the thing becomes very interesting. The question that was asked, locate events within 45 miles of New York in November of 2005. Now, you know, this is a pretty sophisticated kind of a question. And it shows that there is a B, C, D, and E, and if you want to know D, which is on near the docks, on what looks to me like 34th Street, an unsavory district, by the way. It would tell me it's Sol Zanori, and then you can click on that, and you can find out what's going on. And that was 531 West 25th Street in the Meat District, and you can then click on it and find out what that is. By the way, since this is typically done as a Google innovation, all of that is called a beta version. They have over 100 beta applications. As you see, report bad item. They are asking the customers. This is one of the major innovations on the part of the Google way of doing things. Is the customer is the test and the tester of the application. What is becoming very important, however, from a standpoint of the future, has to deal with what's called semantic parsing. Because if you will just index on the keywords, you would get just too many answers. And therefore, you really have to parse things in context. And in this particular case, somebody wanted to know Bay Area cooking classes, and apparently there are related items. This is called semantic parsing. This is how your brain works. Your brain basically semantically parses what people say and relates it, what you don't know, to what you know. Now, going to principle number 3, shared data models, I cannot overestimate the importance of this particular development, particularly from the standpoint of national security. You need to have a standard file system on the 100,000s of servers in order to cooperate with one another. Now, the text may be written in Arabic or in English or whatever else, but nevertheless, from a structural standpoint, they must be interoperable. And that must be able to be scheduled so that somebody asking a particular question can get the answer. And therefore, what I'm trying to tell you here, if you ever want to build for an organization like DISA, a Google-like system, you have to think very hard about the kind of environments that you are going to put into the infrastructure in order for that environment to be responsive to what increasingly in the battlefield becomes a totally ad hoc, unprecedented inquiry or request for information. So the entire engine of data, of files, is based on a metadata directory. I don't want to go into the subject of metadata directory. This is very important. I must tell you that the Department of Defense spent a great deal of money in the 1991-1992 period on building a metadata directory so that friendly fire would not take place because the data were, or the coordinates were not compatible. I'm alluding to something that really happened. So that means that the data transfers, if you have 1,000 servers cooperating, the data transfers from machine to machine must take place at the machine level because of the speed. You know, again, if you are shooting for redundancy, recoverability, and low latency, the data transfers cannot negotiate meaning. And that means that you must have extremely fast processing taking place within the system in order to be able to execute the transactions. And again, the chunks, as they are being processed, are triplicated again in case something gets lost. So the entire network is probabilistic, non-deterministic.
They are, here is an example, for instance, of a data dictionary for interoperability. And by the way, this is the data tags which are available to developers. So for instance, the Google Map environment is now available to developers to integrate into their own application. Now, in order for my application, which may be organization specific, and for instance, if I'm the head of Maxwell House Coffee and I want to know which stores or which neighborhoods are big consumers of Maxwell House 1 pound drip coffee cans, I would then construct an application and then go to Google Map using their tags in order to feed my Maxwell House application from the map so that the map display then can show where are the stores where the coffee drinkers are. Which leads me really to the whole issue of APIs. This is the key to the future of network-centric operation. You cannot rely on a single organization. Google has only 6,000 employees, and they are very choosy about whom they actually pick. The objective really is to engage developers, thousands and 10,000. If you want to take one hot tip away from a career standpoint from this presentation, the young students here is, if you really want to make lots of money, sign up as a Google developer, and you're going to mint money. Not much, but you're going to mint money. And so you can then create environments by using their hooks into the database which is out there, which is growing, and then coming in and interfacing the environment to this API, which then fits the massive parallel computer with your particular application. Of course, this feeds directly into principle number 4, which is upgrading innovation. This thing will not work unless it's dynamic. I mean, you must understand there are lots of search engines out there. Search engines are not that hard to put up. What is different here is that we have created a massive parallel computer that's growing and that's sucking in data and then makes available the possibility to very quickly use the infrastructure without incurring the cost of the infrastructure and then grow your application on top of it. Here's a partial list, which you ought to become acquainted with. Some of them are very neat, very sort of smart. Many of these are still experiments, but many of these online services have been fielded in less than 3 months by a team of programmers of less than 3 or 4 people. They have a server, a cluster developed strictly for development, and all the Google people are encouraged to spend at least 1 day a week paid time to play around with innovation. Yeah, that's a fun thing to do if you are lucky enough to have that privilege. And so you can then do an infinite number of things. This one I like. This is called Frugal. And all of these things get very cute, of course. But you can now use the massive computer to extract from Samsung, who is a vendor, not only the catalog of what they have, but also the manuals. For instance, I've got lots of electronic widgets, and I used to have this big folder full of manuals, which were always obsolete. I don't have any manuals anymore. I just go, and if I look for something, I just Frugal the manual for a particular contraption I have, and I get the latest release. and can analyze it. And of course it tells you where you can buy it, and then you can put cute things like the price range you want, do you want it stores which are nearby, and so forth and so forth. And then of course you can do experimentation. This is clearly an environment that encourages innovation and should be a prototype of how our new transformational efforts in both in national intelligence and in defense should be guided. Here's an example, because I mentioned that I will put all of your inquiries on my blog. Again, this is an application which is inside Google. In 15 minutes, I could put up an application with my picture, with my archives, and with a whole history, so that I don't have to really just do things by email. I can publish a bulletin board and have a conversation which is open then to comments by all the other people who read it. Now, all this thing is sort of interesting because there's a limit how far you can only go from the massive parallel computer. You actually, for certain applications, you have to start occupying the desktop. You have to start occupying the input-output unit. Here is a Google Video Viewer. I don't want to get into the details. This is very sophisticated, but it means that in certain instances, you have to put a handle into your machine in order to interface with a particular application. Now, whether this is an attack on Microsoft is being debated as we stand here. And of course, that means that for the first time, I have to identify myself as a person. And this is the beginning of what may be membership or security in participation in a network-centric environment. So let me now conclude. And I understand that I had 60 minutes. Don, is that correct? Let me leave with you a set of comparisons so that you can relate what you have today and what you know to what most likely is going to happen. The world today can be represented by this diagram. The blue dots are servers, mostly Microsoft servers. And then each server is a little island owned by a sysop or by an operator or by a unit or contracted to a particular contractor and so forth. And there's zillions of them all over the world providing employment to people who then must do the updating, do the defumigation, or whatever you call the elimination of viruses, doing the updates that come in almost weekly, and so forth and so forth. So this is the application. Workgroup computing today is millions of local applications and local data. The only analogy to this world is Europe in the 12th century, where every little town had their own shoemaker and their own cabinet maker and their own spinner and so forth. No economies of scale, and this was basically a craft environment. The problem with that environment is that it's very vulnerable. When you look at the vulnerability today, this is just came out, is you see that in order for these little enclaves of computing to manage themselves in an era of increased complexity, they are adding code and complexity and adding hardware. And every time they do it, they become more vulnerable. So we are coming to an end of a period where both desktop applications, and let's face it, 92% of all the desktops in the world are Microsoft desktops. And the cross-platform applications are increasingly vulnerable to attack and compromise. By the way, there are other systems, certainly Unix systems have other vulnerability, but, and then of course Cisco systems that deal with the switching also are vulnerable. But the fact that we have designed network switching separate on the Cisco from the WANs and from the LANs means that each of them stand on their own. Each medieval town had to have their own defenses, their own moats, their own guards and so forth when the Turks were coming, and didn't do very well when the Turks came in massive ideas. I'm talking from history of the town where I come from. The new internet, as I see it, is that there's going to be billions of browsers. And I mean literally billions. Every cell phone is a browser. And you have browsers which are music browsers, and then you have iPods, and then you have, you know, an unlimited in degree of imagination for doing this thing. And they have to all share, because each of these browsers have to be a window into a multiplicity of functions. And therefore, that is where we are going as an architecture. So where does it all add? The strategy of the last 20 years has been capture the desktop. That was done very successfully, very constructively by Microsoft. And they deserve all the billions of profits that they got out of it. The new era is that the desktop is not a sustainable defense position for anybody anymore. And the only defensible position today is those who can occupy the internet. And by the way, this does not have to be one company. Multiple organizations can occupy the internet. And the internet would be a different internet than what we have today. Now, what is different from an economic standpoint is that in the workgroup-centric environment, the vendor sells you the software license, and you put in the labor and capital costs. You take the risk, the vendor takes no risk at all, and you have no recourse. The network-centric environment fundamentally changes the economics by placing the labor and capital into the network, where there are huge economies of scale and where the knowledge capital, which is a term I will be using in my next presentation, my third lecture, is really dominating the solution. The workgroup-centric environment created isolated silos, or whatever term is being used these days, which are user-specific infrastructures. The problem is that the infrastructures are trying to communicate with one another, and it's done with great difficulty. You must have an infrastructure that's universal. Certainly from a national security standpoint, that is necessary. Now, the problem with workgroup-centric environment is there's too much labor, too many consultants, too many interns. No disrespect to the interns who are making a good living or paying for their tuition. No, it just means that the user has put moats around this little castle, and there is lots of labor to control what happens inside the castle. The Google approach basically is that this is too complicated. It cannot be done by users or by people. It has to be automated. The workgroup environment is operating system dependent, increasingly more and more bloated. The network-centric environment must be open source browsers. You have a totally different economic model, which really deals with demand, pricing, and most importantly, has to do with intelligence. Data read from file has no context. It is a data, and then your brain has to look at gaze at the screen and figure out what it means. And as the amount of data increases exponentially, the brain cycles are not good enough to deal with that. So what you need to do is to assemble data only in context. If you are an infantry platoon leader in a ditch somewhere in front of some godforsaken village, you don't want to have a data dump from a satellite at 10 gigabytes. You need only an answer to a very simple question about, is this village safe, or has it been tested out, and do we have somebody in there that we can trust? So the future, as I see it, is that everything will be on the internet. Everything. Your cell phone, your oven, your refrigerator, everything that's electronic, your electric meter running, your car for maintenance, real-time maintenance, doing preventive maintenance on the car. And this already is happening today. There are cars which have a GPS built in and a diagnostic that transmits to General Motors for, if you paid enough for a car, you get that kind of a service. And that means that all data, voice, video, and sensor input will be accessible selectively as needed. And that means that if you want to be in the telephone business, the TV business, or the print business, the newspaper business, you better get yourself a second job to get ready for the time when people will start dismissing staffs from these organizations. The future is in services, not in technology. Services that respond to questions as needed by the consumer. Information is displayed in the context that is relevant to the culture, personality, and habits of the customer. And the applications are there for making decisions. What do I buy? Where do I go? What do I avoid? Now, why is this important? Our whole national security environment, whether it's Homeland Security, Department of Defense, or intelligence, really depends on the ability to have a superior intelligence in order to deal with the challenges, competitive challenges, which are economic, and terrorist threats of the 21st century. We cannot do it with work groups anymore. We must transform, and the term is transform, to network-centric services. And we don't have much time to do it. Now, you cannot just go in and blow up what you have today. You must be able to migrate. And the way you migrate through displacement. In other words, leave what you have and put the new stuff, and then build it and they will come, as those of you who have seen the movie. Build it and see, and let the customer decide whether they get viable service. And then pocket the money, which today is getting scarcer and scarcer, and invested in innovation. So in conclusion then, I hope that the relevance of Google as a future vision of the environment, it would be something that will be useful to you, and I certainly wish you well, and I will answer any question that you submit to me by email. Thank you very much.